Hello everybody, it's another holiday season and I have time to try another game. This time it is Human Resource Machine. This is a pretty old game released in 2015, but just yesterday Epic Games was giving it away for free and I was able to grab it. Even today though, it is still on sale at a very good discount, so if this game looks good to you, then go ahead and give it a try yourself. From what I know of this game, this is basically a straight up computer programming game, which is basically my day job, so I expect to breeze through it very easily. And I'm not special in any way. I'm pretty sure anybody who has studied the same things I have will be able to do the same. That's just the nature of this game. It's basically a tutorial of computer programming using actual concepts in computer programming. So with that said, let's go. Okay, let's start a new game. Please select your employee ID. Just pick the first one. Photo looks just like me, huh? This is my badge. Proceed to the elevator. Okay, first level, mailroom. Welcome to your first day. You look like an excellent instruction follower. Your first job will appear over there on the right side in a moment. Remember, you can always ask for help. Okay, drag commands into this area. Your program should tell your worker to grab each thing from the inbox and drop it into the outbox. Okay, so take in, out, in, out, in, out. I have 3 things here, so that should work. Yep, that's a very brief tutorial on inputs and outputs. Second level, busy mailroom. Well, it looks like you've made it this far. Congratulations on your promotion. Most people stress out and quit before making it this far, but I can tell you have a bright future in outbox management. Here's your new assignment. Grab each thing from inbox and drop each one into the outbox. On your command, you can drag jump arrow to jump to different lines within your program. Accessibility, you can complete this assignment using only 3 total commands. Yeah, so jump is going to be basically you can jump all the way back to the beginning, so you can keep repeating this in a loop. This is a tutorial on basic loops. Copy floor. Oh no, the inbox conveyor system is completely broken, but that doesn't mean we get to take a break from work. Okay, ignore inbox for now and just send the following 3 letters to outbox BUG. Facilities management staff has placed some items over there on the carpet. If only there was a way you could pick them up. Okay, okay, we're supposed to ignore the inbox, but what does copy from do? Okay, copy from this guy because we want a B first. Put that in the outbox. Copy from you, outbox. Then copy G, put that on the outbox. Okay, I'm assuming this is like a tutorial on memory. This is your input, but the stuff in the middle is basically the computer's memory, and you can copy values from memory. Number 4, Scrambler handler. The conveyor system is fixed, just in time for you to get to work. Data won't collate itself. Grab the first 2 things from the inbox and drop them into outbox in the reverse order. Repeat until inbox is empty. Okay, 2 things from inbox and drop them in reverse order, okay? And your command, feel free to copy 2 wherever you like on the carpet, will be cleaned later. Okay, so I can grab the 2 first, but I don't want to send it to the outbox right now, so I'm gonna put that into memory, copy it to this position. I'm going to grab the second one, which will be the 5, and this one I'm going to send it to the outbox right away. So the 5 goes in outbox first, and then I'm gonna grab whatever I stored over here and send that into the outbox. And I would just keep repeating that. I think that would be correct. Yep, and so this is extended tutorial on memory. Last time you only read from memory, but this time you can write to memory. Coffee time. Okay, it's literally just coffee time.
To work, everyone.
Regions of the city continue to experience power failure. Local authorities are investigating.
Alright, number 6, rainy summer. Welcome to my personal rain cloud. I was never very good at math, since I have only 3 fingers on each hand, but I hear you don't actually need to know very much about math to complete these assignments. Well, 3 fingers should be enough, and computers only use binary. That's 2 digits. For each 2 things in the inbox, add them together and put the result in the outbox. You got a new command. It adds the contents of a tile on the floor to whatever value you're currently holding. Okay. So this time, instead of swapping them, all we need to do is add them. So it's basically the same thing as before. So inbox, I'm gonna stick to memory, and then I'm gonna grab the second one and I'll add that to whatever I stored in memory. Add them together, put the result in the outbox. So let's put that in the outbox. I don't think I need anything else. Make it a loop. Okay, looks like this side is shorter, so I'm going to do that first. Tripler room. Who are you? This optional area is for high-performing employees only. Is that you? Well, you're late. 7 years late. Wait, you were labeled 9. I didn't even do 8 yet. How am I late? We need to make some changes around here. I want to see 100 performance increase. From this point on, your performance will be evaluated with extra scrutiny. Okay. For each thing in the inbox, triple it and outbox the result. Self-improvement, where are we going with this? Please leave the high-level decisions to management. Okay, triple it. We don't have multiply, but tripling is basically this add to itself 3 times. So, inbox. Basically what we did last time, copy to this location, and then we don't need to grab another number. We just add this and then add another copy so that we have 3 copies of the same thing. Send the result to outbox and jump. I think that'll do it. Yep. Okay, we have a challenge, so size and speed are both okay. Sure. Number 10, Octoplier suite. Yes, you can always check your own performance on each assignment's optimization challenges. The 2 green lights next to each button in the elevator will tell you how you are doing. Is there anything in life more thrilling than self-improvement? Okay, for each thing in the inbox, multiply it by 8 and output the result. In outbox, using a bunch of add commands is easy but wasteful. Can you do it using only 3 add commands? Management is watching. Yeah. Yeah, you can add the same thing to itself 8 times, but that takes a lot. But what you can do is each time you add, you're essentially multiplying by 2, and so if you multiply by 2 3 times, that'll be multiplied by 8. So, always take a number from inbox first. And then you want to add it, you want to put this in here. Okay, add it to itself, that's the first time. You get twice what you have. Now put that in here. Add it to itself again. That'll give you 4 times the original number. And then if we do this again, one more time, that'll give you 8 times the number. Send it to the outbox and repeat. Okay, no. That's right. Stop. This one is the wrong number. I don't know how that happened, but anyway. Let's go. Okay. And we got both challenges done, so that's great. Tetracontiplier. Okay, how many do we need to multiply this time? What a wonderful feeling when all your work over the past few years all comes together and culminates in a well-executed assignment. For each thing in the inbox, multiply it by 40 and put the result in the outbox. Okay. Hold on a second, I'm going to draw this out. Okay, so this task is basically an exercise in implementing multiplication inside a computer, which luckily I have actually done before in the Factorial Belt computer series. So we are tasked with multiplying a number by 40, which if we write out in binary is going to be 101000. And the way we multiply them is by working one digit at a time. So the first digit in our binary representation is 1, and that corresponds to 1 times the original number. Let's call that x. Every time we add a new binary digit, we need to multiply the previous result by 2, and so now we have a result of 2 times x. The next binary digit is 1. Again, we need to multiply by 2 just because we moved to the next digit, but this time the digit is also a 1, which means we need to add another copy of the value x. So now if we review what we've just done, on the bottom we have 2 times x plus another copy of x, which gives us 5x. And on top, the 3 digits we've done so far, 101, is also equal to 5 in binary. The next digit again is a 0, and so we multiply the result by 2, and repeat 2 more times for the remaining 2 digits. Essentially, this gives us the fastest way to multiply a number by 40 when the only thing we have is the ability to add numbers. So let's do that in the game. Take the inbox, take the number. I will want to store the original number in here. So 0 will be the original number, that's our x. And then I want to add my thing to x. This will give us 2 times x. I'm gonna want to store that in the next slot. So this one holds x, this one holds 2x. Oh boy, okay. Add to this one. So now I will be holding 4x in my hand, and I will want to add another copy of x. So this gives us 5x. I will copy that into slot number 2. And to get to 40, all I need to do is multiply that by 8 again, which we've done before. So add a copy of 2. That gives us, we had 5, this makes 10. Copy that to 2 again. Add 2, this gives us 20 times. And then copy 2 to add 2 again. This should give us 40 times. And then out and repeat. I'm pretty sure that's going to be good. Okay, it is accepting the results. Yay, and I got all the challenges. That's great. Alright, let's go back. Did I miss any challenge? Oh, busy mailroom. I missed this challenge. So let's try that again. Okay. Let's see. How do I view the challenges? Uh-oh. Optimization challenges. There you go. Okay, speed challenge in 25 or fewer steps. You best complete it in 30 steps on average. Okay, so I need 25 or fewer steps, which means I need to have fewer instructions executing for the same amount of work. Yeah, this is a trick called loop unrolling. So basically, if I have the program this way, then every time it moves one item, it needs to execute 1, 2, 3 instructions. It needs to go in, out, and jump. But if I want to reduce that amount of work, then I can just repeat some of these instructions manually within my loop. And this way, it'll use 7 commands to copy 3 items, which is an average of 2.33 commands per item, much more efficient than the 3 commands per item that we had before. And I believe that should complete the challenge. Yeah, so it's not gonna, the program is gonna be bigger, but it's gonna execute faster, and this is one of the common trade-offs that you face in programming. Okay, now we got this challenge. Excellent. Okay, 0 Exterminator number 7. Where do you see yourself in 5 years or 10 years? Probably like 5 floors up. I have a note here from your other boss that says, from this point on, your performance will be evaluated with extra scrutiny. What a treat. Alright, send all things that are not 0 to the outbox. A new command, it jumps only if the value you are holding is 0, otherwise it continues to the next line. Okay, so now we have conditionals. So, get something from inbox, jump if 0. Okay, so if it's 0, what do we do? Send all things that are not 0 to the outbox. So if it's 0, we don't do anything. If it's not 0 though, we are going to want to put it in the outbox, and then we're going to do the whole loop-de-loop thing again. Okay, let's go with that. Yay! Okay, speed challenge. Again, I imagine you would just unroll the loop a little bit. Let's do that. Can I like copy stuff? Oh boy. Inbox, jump if 0, outbox, inbox, jump if 0, outbox. Okay. Okay, did that do it? Yep. Okay, 0 Preservation Initiative. It has come to our attention that the 0 Advocacy community felt the previous assignment was not inclusive. This time send only zeros to outbox. What happens to the other numbers and letters? Management leaves that detail up to you. Okay, send only zeros to the outbox. So again, we need to take something from the inbox, and we need to jump if 0. So this time, if it is 0, we need to get it to move stuff into the outbox. But if it's not 0, which means it's somewhere in the middle here, we need to ignore it and take another thing from the inbox. So we just go back to the beginning, try again. If it is 0 though, we're gonna come down here, put it in the outbox, and then we need a master loop to do the whole thing. Don't tell me I need to unroll the loop again. Okay. Alright, we'll do it again. Inbox, jump if 0, jumpity jump. Back here. I mean, I guess it's possible to do it without copying the whole thing. There are other ways to do it slightly more efficiently, but If the only thing we are concerned with is the number of instructions we have to execute, then this would be fine. Is this right? I hope so. Not enough stuff in the outbox. Management expect a total of 4 items, not 2. Okay, what did I do? Oh, I didn't put the outbox command. Okay. Okay, how about this? 26. I don't have to copy this again. Inbox, jumpity jump. Another jump back into the inbox. Don't forget the outbox again. Let's go. Okay, this time we got it. Number 11, sub hallway. Subtraction? I never learned that in school, did you? We are a good team. For each 2 things in the box, first subtract the first from the second and put the result in outbox, and then subtract the second from the first and put the result in the outbox. Repeat. A new command subtracts content from a tile from the floor from whatever value you're currently holding. Okay. Let's take the thing first. We got our first number. And then what should be our first output? Subtract the first from the second. Okay, so first of all, I'm pretty sure we need to store this number somewhere and then grab another one. So this is definitely how we need to start. Now subtract the first from the second. So that's 8 minus 2. Subtract the first from the second, 8 minus 2. And then sub, this command is going to subtract the content of a tile from the floor from whatever value you're currently holding. Okay, so the floor is going to hold 2, and it's going to subtract 2 from 8, which is exactly what we want. So first of all, sub this thing, and then out. So this is going to give us the correct first output, and then the second output we need to do the reverse. Subtract the second from the first. That would be 2 minus 8. So to do that, I'm going to copy the second number to slot 1. So we still have the correct thing here, but now we need to copy from slot 0, and then we need to subtract 1 from that, and that'll give us the second output. Jump all the way back. Okay, and both challenges, I'm very glad we don't have to unroll that loop. Number 13, Equalization Room. Sometimes some numbers are bigger than other numbers, and sometimes they are the same. How can we know? I read about that here in this great book. Which number are you for the aspirational 0? You can borrow it later. Okay, this is going to be a comparison thing. Get 2 things from the inbox. If they're equal, put one of them in the outbox. Discard non-equal pairs. Repeat. You got comments. You can use them if you like here to mark sections of your program. Oh, right. I don't need comments. Can I delete that? Yeah, I don't need comments. I don't write comments in my code. If they're equal and... Oh, this is a common command, yeah. So I imagine some people might get stuck here because we don't have an equal command, and we don't have like a comparison command. So what we actually do is take the inbox, copy it to a slot, take another inbox, subtract it from what you just stored. This will give you this number minus this number. And if they're equal, the result is going to be 0. If they're not equal, the result is not going to be 0. So we can use jump if 0 command to make the choice. So if they are equal, that means they are, if it is 0, then that means the two numbers are equal, and we need to put one of them in the outbox. So let's pick up the number that we stored, put that in the outbox, and if it is 0, yes, okay. If it is 0, we want to do that. If it is not 0, we're stuck in here. We want to go back to the beginning and take two numbers again. And then we'll do our master loop. Let's go. Okay, speed challenge. I mean, I could unroll the loop again. There might be more efficient ways. I'm not going to show that, just because it's pretty repetitive. Number 14, Maximization Room. There's been a change of plans. The accounting department has determined that treating all numbers equally is no longer profitable. Management wants the bigger numbers only. Grab two things from the inbox and put only the bigger of the two in the outbox. If they are equal, just pick either one. Repeat. You got a new command jump. Only if the thing you're holding is negative, less than 0. Otherwise, continue to the next line. Okay. Yeah. Same idea. Subtract the two. If it's negative, then you know one of them is bigger. So. Let's grab the first one, store it in the slot, just like we did last time. Grab the second one, subtract. Okay, now this time I want to get the ordering right, because we're doing the second one subtracting the first one. So if it is negative, that means the first one is bigger. If the first one is bigger, we're going to have to copy that number from what we have. Oh, wait, we don't have a copy of the, we can't pick up the second one either. Okay. So let's store both numbers over here, subtract them, but once we subtract, we're going to destroy the original two numbers. So we still need both numbers to be stored here. If it is negative, that means the second number is smaller, so we need to grab 0, put that in the outbox. Whereas if it is not negative, that means we can grab slot 1, which was our second number, and then we can jump over here and output. I think that's all we need. Jump back to the beginning. Yay! Oh no! Both of my challenges are not met, so I need to make this a little bit more efficient. Alright, how about this? I have been copying the second number to memory because I needed a way to recover that number in case that was the bigger one, but there's another way to recover that number. So I'm going to still do number 2 minus number 1, and if it's negative, that means number 2 is smaller, and so I can still take the first number, copy the first number, send that to the output and jump. So that branch is perfectly fine. If it's not negative though, I don't have the original number stored anymore, but what I can do is add this number back. So I took the first number, stored it here. I took the second number, subtract the first number, but now I'm adding back the first number. So that should give me the original second number back. And in this case, I can still send it to outbox and jump back. That should be more efficient. Another thing that I thought of is instead of in this branch doing a jump, output, and another jump, that's 3 instructions, I can make it more efficient by just sending it to outbox immediately and then jumping back to the beginning. That way it only needs 2 instructions, it doesn't need to jump twice. Let's try that. Alright. I got the speed challenge, this is good. Size challenge, I'm pretty sure I can do that. This is because I added an extra outbox instruction before. So if I just restore how it was previously and delete that outbox instruction, I should get the size. Alright, perfect. And the speed is also good enough. Last time my speed was even lower, but I guess I didn't need that. Alright, so that was a pretty good challenge. I was expecting the entire game to be easy, but it turns out that's not the case. I mean, the basic task of doing each level is pretty easy, but these challenges actually make things a little bit harder. So let's watch the coffee break. Employee morale insertion.
And that, ladies, is how I saved a bundle on my long-distance telephone service. Back to work, everyone.
A massive army of machines has surrounded the city. The machines are not moving, and they are not communicating. Local authorities are investigating.
Okay, I think that'll be it for the first episode. We'll pick up the next level, Exclusive Lounge, next time when we come back. Thanks for watching. Actually, let me go back and do the second challenge for Equalization Room. Here's an idea. I'm looking at all these jump instructions and that looks a little bit messy and inefficient. So what if, when we jump if 0, I put these instructions at the top? So jump if 0, it actually comes up here and does that. That way we don't need 2 jump instructions to be executed every time, because they now jump to exactly the same target. So I can remove one of these. Now, initially I won't be able to do this, so that we need a way to skip past these commands. So what happens is the first time I want it to start by taking something from the inbox and doing all this. If it's 0, then it comes over here in outputs, which is what we want. If it's not 0, then it goes back and takes stuff from the inbox. That should remove some extra jump instructions and make it execute more efficiently. Yes. So that's a better way to do the challenge. And I also realized it's not necessary to unroll loops from some of the earlier levels, including number 7, Zero Exterminator. So let's get rid of all this stuff because we don't need this stuff anymore. All we need is for this to be a little bit more efficient. I realized if you are 0 and you jump over here and you do another jump, that's 2 jump instructions, whereas you could have just jumped to the beginning directly, and that's only 1 jump. That'll save a few jump instructions. Yeah, and that is good enough, so no need for loop unrolling at all. Same thing with number 9, Zero Preservation Initiative. Yeah, this is a giant mess. We didn't need any of this, I imagine. Yes, I know that. Outbox. Okay, this was our original thing. Oh yes, we could use the trick to move the outbox instruction to the top, and that way jump if 0 goes over here, and we can remove one of these jumps because the jumps will be redundant. We need one instruction to skip the outbox in the beginning of the program, but that's only going to only going to execute once. The rest is going to have a reduced number of jumps. Perfect. And that's a much better way of doing things. Alright, this is the real end. Thanks for watching. See you next time.